activity I'm going to share with you that we had wind-up toys and we measured them, how long they went and how far they went, how much time and distance. Because we learned last week that motion is the change in an object's position. Take a look at my head. Look what's right behind my head. Stare at my head. Shut your eyes. Now open your eyes. Is the same thing behind my head?
No.
Did I move?
Yes.
Did you see motion?
No.
Okay, keep your eyes open this time. Ready? I'll do it in slow motion. Did you see me move then?
Yes.
Oh, so you can see slow motion. You can't see fast motion. Ready? So motion is the change in an object's position. You learned that last week. I'm going to show you what we learned. Click on the student findings right up here. See where it says, click on that. And the student findings, this was our question last week. What is motion? In about 3 seconds, you're going to see some slides. Ding, 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 ding. And if you hit up here where it says present, right above my finger, move over mouse, move over mouse, move over mouse, move over mouse, move over. Right there. And then, so what is motion? That was where teachers and kids will insert their findings, their conclusions, their images, questions about the lesson. Go ahead, hit the next button. So here's what you did. And if you haven't done this, teachers, I highly recommend you go back because each lesson builds on the next. So in your science kit, you have all this stuff. Next. So that was Sebastian, and this was over at Maplewood. We were observing. Next. Here's Melanie's journal, and these wind-up toys used energy, and they moved. We timed them, and we measured them. Next. And so I really loved how these kids write in their journals and write on their science workbooks. Go ahead. You just see some of the things. Seth said, no, we should put it under technology with the car and the cell phone because it uses an engine. And Caden said, I know the apple fell because of gravity. That was kind of cool. Next.
Awesome.
So here's pictures, teachers, of their journals. Go ahead. You see, tomorrow at this time, I'm going to ask you to send me a student from each class down, and we're going to videotape live what you guys learned. You put your slides up. Go ahead. Next one. And next one. And next one. And then it could be just some journal entries. Okay, go ahead and escape out of that. And let's go back to the grid. There you go. So these are other things your teacher's doing with you all week long. This is what I do with you, and this is on Tuesday, Wednesday, and Thursday, other things. So you have 4 things to do each week in science. And a new question. This week's question is, how can you change how things move? So last week we talked about things that move. Today we're going to talk about how things, can we change it? Can we change it? For example, I let go of this, gravity pulls it down. It moved in the same way. It'd be a strange day if I let go of it and it stayed there. But we can count on gravity. It's a law. But how can I change the motion? Change the motion, I can make it go faster, slower, or a different direction. What can I do? Any ideas?
Twist it.
Twist it. Oh man, look at that. See, this is motion changing. Did that change the motion?
No.
Oh, I can do this. Go it up and down. That changed the motion. Here's another one. Ready? That changed the motion. I don't know if I can drop it in slow mo. No, probably can't.
Do it.
Try. No, can't. So we are going to investigate how we can change the motion of something. And what we're going to do is we're going to investigate how we change the motion of an airplane. You're going to use science methods and design methods to make an airplane like this. It's called the FPG9, which stands for Foam Plate Glider, 9 inches. And we're going to make it first, and then we're going to test it. And it's easy to fly. And if I get it right, it flies like this.
Whoa!
So, are you ready for that?
Yes.
Okay.
No. Yes.
Okay, so to make an FPG9, first you have the wing and the tail. You separate the tail off the wing, and this is the tail. It's rounded. It has 2 little slits right here for the rudder. That's the rudder that moves back and forth. You take your scissors, and we need to make this part a little bit wider so the tail will fit into the wing. So here's the wing. It has a center part right here that I need to make a little bit wider because everybody knows that all things are made of matter, and matter takes up space and has mass, and so we can't have 2 things in the same place unless I remove something. So now it fits, and I put it together. It should be up nice and straight. We call that a 90-degree angle or perpendicular, but this won't fly unless it has a pilot. So I like to use Abraham Lincoln. Why do I like to use Abraham Lincoln? He's cheap. He's 1 penny. And he's got a hard head made out of copper. And so if he crashes, he'll be safe. So first let's put his seatbelt on, put him right in the middle. The reason I like to put him in the middle is because I want my plane to be balanced. Then I need to close the cockpit lid. So I close the lid, my second piece of tape. And now, most important, I need to put my name on this, Rick, and it's the FPG9, which stands for Foam Plate Glider 9-inch. You have the pattern, you can make more of these at home. So now I have some little slots right here. Just like I had a rudder on my tail, I have these two things called elevons. And they move up and down. So I can move this one up and down, and this one up and down. All I have to do now is put my tail on my wing. Dun, 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 dun. It's always good if you have a shark sound when you do that, because you want the rounded leading edge that way. I'm going to put one piece of tape here to hold it on. See how I bent that over? And I'm going to put one more piece of tape on the other side to hold my tail in, making sure that when I look at this, it is 90 degrees. And now I'm ready to test this to see if it'll fly straight, and then to see if I can make it a change in the motion of this plane. Got it? Good. Take your airplane, your FPG9. Now, you guys are actually following in the footsteps of some famous engineers and scientists called the Wright brothers. You see, over 100 years ago, they used the design process to make the first plane that flew. If you look on page 55 right here, this is the design process. Identify the problem. How do you make a plane that you can control? Do research. Develop a possible solution. Choose one solution. Design and construct a prototype. You have in your hands a prototype. Test the prototype. In just a moment, you're going to test it. Communicate your results. You're going to write down how it flew. And then evaluate and maybe make it better. So, right here, take your airplane. Let me tell you about the Wright brothers, what they were trying to do. And they made kites, and they made models. An airplane can go up and down. Show me this. This is called pitch up, pitch down. Pitch up, pitch down. An airplane can do this. Roll left, roll right. Roll left, roll right. And then this is the weird one. An airplane also does this. Yaw, 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 yaw. So, when an airplane is flying, the pilot has to control all three of these. What's this one called?
Pitch up and down.
Pitch up and down. What's this one called?
Left and right.
Roll. And what's this one called? Yaw. Look on your worksheet right here. On the bottom of your worksheet are the three ways: pitch, roll, and yaw. Got that? Okay, now look back in your books on page 56. Later with your teacher, you'll go over these pages. You see drawings of George Cayley from England, Sir Cayley, who made a model. And the first person that ever flew in a model was a young boy from a farm. And then over here, we have the Wright brothers. We even have, on airplanes that you see fly over your school, there's rudders, there's ailerons, elevators. And I like the word elevator because in science we use words like elevator. It has the word elevon. These are elevons or elevate. The word L means to go up. When you go up an elevator, it goes up, right? Up and down. So we don't have a devator, we have an elevator. Okay, so in fact, look on page 59. This is the very first plane that the Wright brothers, it's called the Wright Flyer, and some cool things happened, just like your model. It was heavier than air, it wasn't a balloon. It did have a pilot. It did have an engine. And more importantly, they could change how it would fly. All right, are you ready for that? Here's what we're going to do. On your worksheet, you have, take a look, there are 4 practice flights you're going to do in your room. Not in here, but back in your room. 1, 2, 3, and 4. The job of that is to make your plane go straight. So I'm going to do one practice flight right here. Watch. I'm going to see if my plane, I'm going to move my rudder to the right. There's my rudder right there. So don't move yours yet. I'm going to fly this. I'm going to make my rudder to the right and see what happens. I hope it goes straight.
Whoa.
Oh, do you see it went to the right there? So here's what I would do. Look at my drawing over here. So flight 1, I moved rudder right. And how did it fly? It went like this and then curved a little bit at the end. So on flight 2, I will do one more change. Then on flight 3, one more change. Flight 4, one more change. Now we get to the experimental flights. Look here, experimental flight. Here is where I want you to make a change. Hand me my plane for me over there, please. So here's something I might try. Check this out. After I get it 4 flights to go straight, you know what? I'm going to put up elevons. I'm going to make both these elevons go up. And I'm going to see, how do you think that will change how the motion is? Will it make it go up, down, roll, or yaw? What do you think? Up or down? Let's see. I have up elevons. Let's see if I can change the motion of this thing. Here we go. Ready? Oh, you see? Did you see it go up? Okay. I have one more test. Your teacher, you believe in science?
Absolutely.
Okay, you stand right there. Now, I'm going to aim for your face. Oh, I like it. Nice face. But do you trust me?
I trust you.
I'm going to put down elevons. If I put down elevons, where should the plane go?
Down.
Oh my goodness, this is the dangerous part. Boys and girls, no teachers were harmed in the making of this video. We hope. Here we go. Down elevons. I'm going to aim right for your face. You believe in science?
I do.
Here we go. 1, 2, 3. Hey, I was able to control the flight. Now, it's only fair that you fly it at me, right? Oh. Okay, so what we're going to do, I'm going to show you one more thing. Okay, so we're here at McClellan with the 4th grade, and we're outside and we're going to test our FPG9. It's a bit windy. Weather conditions could be worse. They could be better. But let's have a test flight. Your name is on them. Everybody back by the grass. Back by the grass. This is Indianapolis International Airport flight traffic control. We have been cleared for takeoff. Elbows up. Hold it from underneath. Check the sky. No birds, no other planes, no balloons. Ready, set, fly. Okay, we have one more flight. Everybody's made their FPG9s. We're outdoors. We're going to fly into the wind. 1, 2, 3.